One more kind of test that's valuable in clean architecture and in ASP.NET Core in general is functional tests. These are tests that verify the functionality of your system from a perspective of a client. And in case of a RESTful API, running end-to-end tests involves calling the API endpoints. So in this lesson, I'm going to show you how to write functional tests. Let's go ahead and define a new class inside of our Bookify API functional test project, and I'm going to call it the functional test web app factory. I will make this class public, and we're going to follow a similar format to what we did in the integration test web app factory. In fact, it's going to be almost identical with a few more things added on top to facilitate functional testing. I'm going to define the Postgres container, Redis container, and Keycloak container, the same as we did in the integration test project. I also have the Bookify Realm export file present in my functional test project, and it's set to copy to the output directory if there is a newer version. Next, I'm going to configure the web host services. And again, this is pretty much identical to our integration test setup. So we are removing the DB context options registration and adding the database context again, this time connecting to our container instance. We're doing the same for the SQL connection factory, which we cannot see because it's internal, so we will have to add the functional test assembly using internals visible to, and now if I go back, I will be able to reference the SQL connection factory. I'm updating the Redis cache options to connect to my Redis container. Next, I'm grabbing the Keycloak base address to configure the Keycloak options. So up until this point, there is nothing new. However, the next thing I'm doing is configuring the authentication options. And to be specific, I'm setting the issuer and the metadata URL to point to the Keycloak instance running inside of my Keycloak container. I also need to update this property to have a setter, so that I can update it from my test setup. And this part here is very important because it's going to configure our JSON Web Token validation parameters. When you are running functional tests, you are pretty much calling your API as an outside user, which means that you will have to authenticate with your API by specifying a valid JSON Web Token. And I'm going to show you how this works in action in just a moment, but let's add a few more things that are remaining inside of our functional test web app factory. I'm going to add the initialize async method. It's almost the same as before. We are just starting up the container instances with the addition of the mysterious initialize test user async method. I'll show you what the implementation will look like in just a moment. In the dispose async method, I'm just stopping the container instances, and let me implement the initialize test user async method. So what I'm going to do here is call the create client method on my web app factory instance, and I'm going to get back an HTTP client that is configured to call the Bookify API in memory instance. Then I can use the HTTP client to send a post request to the register endpoint, and I'm going to specify a test register request. Let me add the users folder in my functional test project, and I'm going to add my test data class. It's a similar idea to what we used for unit testing, except this time I'm creating a registered user request instance, and I'm going to use this to initialize a test user with a dummy email and a dummy password. So if I go back to my functional test web app factory, you can see that my setup is pretty simple. I'm just calling the register endpoint and passing in a valid request. And this is going to invoke the endpoint on my user's controller, create a command instance, send it using Mediator, and it's going to connect to the Keycloak instance running in the Keycloak container, register a user with Keycloak, and also persist that user inside of our database. So we are making an end-to-end test inside of our system, calling the API, interacting with Keycloak, Redis, and the database, and returning a result back. And this is a very powerful way to be writing your tests. And this wraps up our web app factory implementation. Let's go ahead and create a class fixture. So I'm going to add a new class that will be the base functional test. I'm going to add the implementation here directly, and I'm going to show you what we have inside. I'm implementing the iClass fixture and specifying my functional test web app factory. I'm using this factory to create a protected read-only instance of an HTTP client, and this is what I will be exposing in my functional tests to call the respective API endpoints. I also added a helper method that's going to allow me to obtain an access token using the email and the password of our test user. You can easily extend this to accept an email and a password as an argument, and it's going to give you back the JSON Web Token for that user. And now let's start writing our functional tests. I'm going to add a class in the users folder that I will call the register user tests. This will be my first test case, and it's going to implement the base functional test class, and I'm going to add the constructor implementation. Let me define my first test case. It's going to be an asynchronous test, and because we are running the register endpoint, let's start our test name with register. I'm going to say that the register endpoint should return an OK result when the API request is valid. Let me add the arrange, act, and assert steps, and let's see how I'm going to write a functional test. So first, I need my API request instance. Now, because I'm using strong typing, I define a request object for all of my endpoints. For the register endpoint, this will be a register user request. Let's pass in an email value, for example, create@test.com. I'm going to use first and last for the first name and last name value, and let's pass in a simple password of 1, 2, 3, 4, and 5. Then I'm going to use my HTTP client instance to post my request by using the post as JSON async method. This is an extension method that allows you to send in an object instance, and it will take care of serializing that to JSON. However, I first need to specify the route to my endpoint. So this is going to be API version 1 and then users register, and then I can pass in my request object. If you have multiple versions of your endpoint, you definitely want to be testing all of them. And for the assertion, I'm going to say that the response status code should be, and I'm going to say HTTP status code OK. And this is all I need to write a functional test. I just need to define my API request instance, send that using an HTTP client, and verify the status code that I get back. Of course, if you want to, you can make this more complicated. You can verify the response content that you get back from an endpoint. If it's an unsuccessful API request, you could verify that the error codes that you get back are the expected ones. Let's give our functional test a try, and I'm going to place a breakpoint here and start debugging our first test case. It's going to take a few moments for us to hit this breakpoint while the container instances spin up in the background, but eventually we're going to land on this breakpoint and we will be able to run our test case. I landed on the breakpoint, so let me step through, and now I'm going to send a post request to my API with the registered user request. I'm going to press continue, and we hit the breakpoint inside of the user's controller. So this is practically like testing your API from some API client like Postman, except you are writing automated tests to verify the behavior. So inside of our endpoint, we're going to create a command instance and then send this using Mediator. It's going to run through the Mediator request pipeline, executing any validators that we have, and I'm going to hit continue, and we land in the actual register user command handler. This is going to create a user instance, then it's going to call the authentication service, which is going to talk to the Keycloak instance running in the container, and you can see that we successfully registered the user and we get back the identity ID. Then I'm going to update the user, save this in the database, and if I hit continue, we're going to get the response back from our test case, and you will see that our test is passing. If I want to test validation for my use case, for example, the register user command validator, there are a bunch of rules that I could break, for example, specifying invalid values for the first name, last name, email, and the password. So I'm going to add a few test cases for this, and I will be using the theory attribute from XUnit in order to specify my test data using the inline data attribute. This allows me to take in the test arguments as parameters on this method, and I can use them to initialize a register user request. Then I'm going to send this request to my API and verify that the response that I get back is a bad request. This contains all of the possible variations for specifying an invalid register user request. So let's go ahead and run all of our test cases. And you can see that all of our tests are passing, and this is a quick way for us to add a lot of use cases for our functional tests. Now I'm going to add 2 more test classes and walk you through what we have inside. So first we're going to take a look at the login user tests. It implements the base functional test class. I'm defining an email and password that I'm going to use to attempt to log in to the API, and we're going to be calling the API v1 users login endpoint. We're going to send a login request to this endpoint, and when the user doesn't exist, I expect to get back an unauthorized response, and when the user does exist, because I registered this user with my API in the arrange step by simply calling the register endpoint, then I expect to get back an OK result, and this will also contain the access token. Let's go ahead and run our login test cases. And you can see that both of the tests are passing, and we are verifying the functionality of our login endpoint. And let me add one more test class that is also going to be the most interesting one. This is the getLoggedInUser test, which is going to call our get endpoint API v1 users me, and this endpoint is different because you need to provide a valid access token. Now I'm going to use the helper method that I defined on the base functional test class to get an access token instance for the test user, and then I'm going to set the authorization header on the HTTP client using this access token. I'm also using the authentication scheme constant on the JWT bearer defaults class to specify the authentication scheme on this header, and with the authorization header added, we can go ahead and call this endpoint, and I expect to get back a user response. Let's go ahead and debug this endpoint because there are some interesting things that I want to show you here. We hit our breakpoint, and I'm going to try to get back an access token, and you can see that I'm getting back a completely valid JSON Web Token instance. We're calling the login endpoint on our API instance, which is proxying the request to Keycloak and giving us back the JSON Web Token. Then I'm going to add this as an authorization header, and before I send the GET request to the API, I want to show you the endpoint that we will be calling on the user's controller. This is the user's endpoint, and we decorated this endpoint with the has permission attribute. So anyone that is trying to call this endpoint will need to be authenticated with our API and also be a user in our system who has the user's read permission. So I'm going to press continue, and you will see that we hit a breakpoint inside of our custom claims transformation class, which we added when we were implementing role-based authorization. Inside of the transform async method, I'm going to use the authorization service to obtain the roles for this user using the identity ID, and the response we get back will tell us that this is a registered user in our system. In the remainder of this method, we're going to add the subclaim and the respective role claims. I'm going to press continue again, and this time we hit the breakpoint in our custom permission authorization handler. So remember that we are still running our functional test, yet we are able to verify our complete authentication and authorization implementation for the API. And inside of our permission authorization handler, I'm going to check that this user does indeed contain the permission, and I will end up calling succeed for this authorization requirement. So if I press continue, our test is going to complete, and you will see that our functional test is passing because we get back a valid user from our endpoint. Functional or end-to-end tests are very powerful, and they give you a way to verify the complete behavior of your ASP.NET Core API. You can test the serialization logic, filters, middleware, authentication and authorization, and the response codes that you get back from your API endpoints. The test setup for functional tests is a bit more cumbersome, but the end result is definitely worth it, and at the very least, you should be testing the happy paths in your endpoints using functional tests, because functional tests can give you the highest level of confidence that your system's behavior is correct.